Bismillah, salatu wassalamu ala Rasulullah sallallahu alaihi wasallam. Assalamu alaikum wa rahmatullahi wa barakatuh, and welcome to the new lecture. That is, again we are studying the subnetting. In our previous lecture we have studied about the subnetting of class C, and that was different from this lecture because in that subnetting we have just studied that when we have given an IP address, and that IP address will be subnetted into different subnets. In this lecture we will study that if we have given some requirement, if we have given some requirement of hosts. Okay, what does mean requirements or requirement of hosts? Let's say this is a topology here. This router has two networks, okay, connected, two LANs here. There is one more router that has one LAN here, and this router is connected with the third router, and third router has a LAN here, one LAN or two LANs here. Okay, now we have given the requirement that in this LAN we need 20 hosts. Okay, in this LAN I'm just encircling the number of hosts, the given requirement. Okay, this LAN needs 10 hosts, and this LAN that is connected, sorry, this is not the LAN, this is directly connected connection, it needs two hosts here. Okay, because directly connected with each other, these two routers, so we need only two routers here, and here we need, let's say, 6 hosts. Okay, and these two routers are directly connected, again 2 hosts are required, and here let's say we are saying the 10 host or 12 hosts required. Okay, and in this LAN we have let's say our requirement is 35 hosts. This is called requirement. Okay, this is called requirement of host. Now in this case of subnetting, how we will solve the question when we have given the requirement in case of hosts. Okay, and we have studied in our previous lecture that what are the formula to calculate the number of hosts. If you remember the formula to calculate the number of hosts, then you will easily calculate the number of given host here. Okay, the number of hosts, to calculate the number of hosts, we have formula 2 power h minus 2. Okay, this is the formula that we have studied in our previous lecture, and I will give you the link of previous lecture. If you have not if you don't know that what is the formula or how we got this formula, then you can watch the video in description. I will give you the link there for the previous lecture. So here 2 power h minus 2 is the formula, and we have to calculate the value of h. With the help of this value of h, we will solve all these subnetting questions. Okay, so now we have the formula 2 power h minus 2, and our requirement, we will start from the biggest network, and that is this one, 35 hosts. Okay, we will start from here, 35 hosts, and then we will come to the other requirement that is given here. Okay, let's say I am saying that this is 35, I will make it 20. Okay, I am making it 20 because with the same router it will be easy for you. And here let's say I am saying that this is 12. Okay, this is requirement is 12 here, and I made this one is 20. Okay, now 2 power h minus 2, and what you have to do is this result, the result that you will get from this formula should be greater than or equal to the requirement. Should be greater than or equal to the requirement. We will put the value of h here. We will start from 2, yani 2 power 2 minus 2, and then we will get the value that will be equal to the requirement. Our first requirement is 35 hosts, so r is 35. Okay, so we will put the value here, 2 power h minus 2, 2 power 2 minus 2, that will gives us the value 2, that is less than 35. 2 power 3 minus 2, it will gives us the value 2 power 3, 8 minus 2, 6. It is not fulfilling our requirement. 2 power 4 minus 2, it will give us 14. 2 power 5 minus 2, it will give us 30. Okay, 2 power 5, 32. That is also less than 35. 30 is also less than 35, so we will go for the 2 power 6 minus 2, that is equal to 62. 2 power 6 is 64 minus 2, 62. This 62 is greater than 35. The previous 30 is less than 35. So our requirement is fulfilled here. Okay, 2 power 6. So 6 means H. 6 means H is equal to 6. Now with the help of this H, we will solve, or we will get the value of S. S means subnets, as we have studied in our previous lecture. S means the number of subnets, subnet bits. Okay, these are the host bits, and these all host bits means that these host bits are 0 here in the host portion. As we are studying the class C, the total number of bits in the host portion, is 8. Okay, so how we will get S? If 6 bits are zeros, then we will subtract 8 minus 6, yani 8 minus H. Okay, 8 minus H is 6, so we will get the value of S. With the help of this S, all these are interconnected with each other. All these steps are interconnected with each other. So in the next step, what we will do, we will get the value of subnet mask with the help of this S, value of S. We know that, and we have studied in our last lecture, that when we are taking or borrowing the bits from the host portion, those are the S bits. Okay, so borrow means the total number of bits in class C, the network bits in class C. How many bits are there? 24. And by default or default bits are 24, and host bits are 8. Okay, we have here, in this case, we have S is equal to 2, means that we have taken 2 bits from here. So 24 plus 2, it will be equal to 26. Now our network bits are 26. So in CIDR notation or in prefix, we are writing it is /26, because the default is /24. Okay, /24 is the default prefix in case of class C. Now we got subnet mask in prefix or in CIDR notation. So in DDN or dotted decimal number, it will be equal to 255 8 bits. Okay, 255 8 plus 8 16, then 255 16 plus 8 24, and 2 bits here. And we know that 128 is the first bit, the second bit, there are 2 bits, and 64 here, and the other 6 bits are zeros. So these are zeros, so we will add these two numbers and we will get the value 192. Okay, 128 plus 64, 192. So our subnet mask is 192. Okay, with the help of this subnet mask, in the next step, with the help of this subnet mask, we will calculate the block size or magic number. Okay, magic number or block size. So for the block size, we have studied formula is 256 minus subnet mask. So 256, and we have subnet mask. What is the subnet mask value? 192. 192. This is the subnet mask value. Okay, 256 minus 192, we will get the value 64. Okay, 64. 6 minus 2 4, and 15 minus 9 6, and this will be eliminated. So 64 is the block size or magic number value. With the help of this block size or magic number value, we will get the next network, as we have studied in our previous lecture, that with the help of this block size we will get the valid networks. Okay, we will get the valid networks here, right? So what we will do, let me spare the space here. Now the first network, if the given IP address is 192.168.9.0/24, now the first network starts from 0, so the first network is 0. Okay, the second network will be 64. So this network is having 35 hosts. This network is 9.9.0. This is the network portion, and we know that the network portion remains same in all the subnets. In all the subnets the network portion remains same. So /192.168.9, and that's why I have written here 0, and the 64 is the next network with the help of this magic number or block size. Okay, now the next network is this one. This is the next network. Our requirement is now R is equal to where I should write R is equal to 20 now. Okay, in the first this network we have calculated here the block size value 64, that is the R was 35. In that case R was 35. Now we have R 20. Okay, now again we will put the values here. Already we have written here, and you will see that 2 is less than 20, 6 is less than 20, 14 is less than 20, and 30 is greater than 20. So our value is this one, H. We will repeat the steps. H is equal to now H is equal to, what will be H? H is 5. Okay, this is the 5 through which we got the value 30. So H is 5 here. Now when H is 5, so 8 minus 5, that will be here in this case H is equal to 5. With 5 we will get S3. With S3 we will get this subnet mask, that is /27, and if /27 means 3 bits are on, 128 plus 64 plus 32. So we have the value here, 224. Subnet mask is 224. Instead of 192 you will subtract 224 and you will get the value 32. That is the block size. The subnet mask is /27. For this network the subnet mask is 192. Okay, for this network the subnet mask is 224, or when we are writing in CIDR /26, and for this it is /27. Got it? Similarly we will calculate the next network value. Let's say it is 10. For 10 you can see our requirement is fulfilled here. 14 is greater than 10 and 6 is less than 10, so our requirement fulfilled here. Okay, so again the same steps we have to follow. H is equal to, now H is equal to 4, so S is also 4. If S is 4, then subnet mask is 24 plus 4, 28. Okay, /28 means one more bit is on here, 16 will be added here, and then you will get the subnet mask. 192 was the previous one, 192 plus 16, that will be equal to, what will be the result after adding 1 with 192 plus 16? 6 plus 2 8. Okay, and 9 plus what will be the subnet mask? 192 plus 16, 8, 0 and 2. How it is? So I think I'm wrong here. Let me check again. 128 plus 64 plus 32. Sorry, it is 224. It was 224. /27 is 224. That's why I thought it should be 240. Okay, so the next subnet mask will be 240. Okay, so we will subtract 256 minus 240, that will give us the value, that will give us the value 16 here. Okay, so the block size is 16. Now we will add here 64 plus, sorry, 64 was the previous subnet mask, so block size, and we have calculated the previous block size 32. So 64 plus 32, that is 96, and the next network will be, the next network we have calculated here, plus 16, that is equal to 96 plus 16, 110. Okay, for this network the subnet mask is /28 or 240 or /28, and for the next network we will calculate this one. And here we have 10 hosts, again the 10 hosts here. Okay, then we have to add here /28 again, because 10 and 12 both are here. 10 and 12 both are here, less than 14. Okay, 10 is also less than 14 and 12 is also less than 14, so both have the same subnet mask. And the next network, again, because the block size is 16, so 110 plus 16, it will be 126, and so on. Okay, the last point that we have to understand is the usable IP addresses in between the network address and broadcast address. So broadcast address, as we have studied in our previous lecture, the next network -1. So for cipher network we have, or for zero network we have 63, the broadcast address. For 64, 96 minus 1, that will be 95. Okay, and for 96, 109. Okay, and for the next network similarly 125. These all are the broadcast addresses for these networks. Okay, and in between these network address and broadcast address, as we have studied in our previous lecture, that all are usable IP addresses. These are usable IP addresses like 0, 1, 2, 3 up to 62. Okay, similarly here 64 and 95, so 65 to 94, these are usable IP addresses, similarly in other networks as well. Okay, so this was the class C subnetting, when you have given the requirement and you have given the host values and how you will calculate these host values. Okay, I hope it will be clear. So inshallah in the next class we will study about the class B subnetting, and we will continue our lecture there. Thank you very much for watching the video. Thanks a lot.